Before we dive into today's episode, make sure to hit that subscribe button. It's the best way to stay updated with our latest insights.
Ladies and gentlemen, welcome to the CTSS Academy podcast. The energy is electric. The crowd is alive. Let's dive into greatness. We're champions strong.
Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Welcome back to the deep dive. Today we are strapping on our helmets and diving headfirst into the operational core of large-scale infrastructure. We're talking about network organization.
Specifically, we're going after what I think is the silent killer of network stability.
Which is?
Configuration drift. That and just plain manual inconsistency when you're dealing with huge numbers of switches.
Right. I mean, think about the complexity here. Let's say you manage a big corporate network. You could easily have 100 switches, maybe more.
Oh, easily. Across data centers, different office floors, you name it.
So imagine a simple request comes in. New security policy. We need to rename VLAN 10 and, I don't know, delete VLAN 50, network-wide.
Right.
If you have to manually log into 100 different devices to do that, what's the one thing you can absolutely guarantee?
Errors.
Yeah.
Without a doubt. Misconfigurations, typos.
Yeah.
And that leads to massive downtime.
That exact scaling nightmare is, well, it's the problem that led to the tech we're talking about today.
It is. This deep dive is all about virtual local area networks, or VLANs, and the Cisco proprietary solution that turns that manual slog into something, well, automated.
The VLAN Trunking Protocol, or VTP.
That's the one. So our mission today is pretty straightforward. We're going to unpack what VTP is, understand how it manages these changes centrally, and, this is the crucial part, get into the security and scaling updates that came with its later versions.
We want to give you the shortcut to bulletproof network synchronization.
Exactly.
So let's start with the basics. The V in VTP, the VLAN. We hear the term all the time, but let's just define it clearly.
Okay, so VLAN stands for Virtual Local Area Network.
Right.
Think of it as a custom logical network that you build on top of your physical network.
The power there is really abstraction, isn't it? You can group devices into one single broadcast domain, one logical network, even if they're plugged into switches on different floors or in different buildings.
That's the key. It lets you segment your traffic, which improves performance, and it's a huge layer of security. You can keep, say, the finance department's traffic completely separate from the marketing department's.
And you administer it just like a regular physical LAN, but with way more flexibility.
And VTP is the tool that organizes all of those virtual networks. VLAN Trunking Protocol. Its only job is to exchange all that critical VLAN information, the names, the IDs, all of it, between switches that are connected together.
Over trunk links, specifically.
Over trunk links. And the genius of VTP is its management philosophy. An admin just has to make a change, create or delete a VLAN on one single switch for when you call the server,
and
then that change is automatically sent out, received, and synchronized to every other switch in the same VTP domain. It's a massive time saver, and more importantly, a huge error reducer.
Okay, that sounds fantastic, but now we've taken traffic from dozens of these logical networks, and we're funneling it all down a single physical wire, the trunk line. How does the network not get confused? How does it know which data belongs to which VLAN when it's all mixed together?
That is the critical question. When you combine virtual networks like that, you need a way to sort them out at the other end. VTP uses two main techniques for handling these frames.
Okay.
The first one is called frame filtering. This is more of an internal thing for the switch. It looks at the header information, the abcedrus, maybe some layer 3 info, and decides which VLAN the frame belongs to.
But that's not for the trunk line itself.
No, the real work on the trunk relies on the second technique, frame tagging. This is what makes the whole thing possible.
Tagging.
Frame tagging inserts a unique identifier, specifically the VLAN ID, right into the frame's header as it travels across that trunk. Think of it like putting a colored sticker on a box before you ship it.
So when the frame arrives at the next switch,
that switch reads the tag, instantly knows, this is for VLAN 10, and sends it only to the ports that are part of VLAN 10. This whole process is governed by the 802.1q standard.
Got it. So filtering is for internal decisions, but tagging is the key that lets all these different VLANs share one road without crashing into each other. That clears it up a lot.
Exactly.
Now, if we're relying on everything to sync up automatically, there have to be some strict rules. What are the prerequisites? What has to be perfect for VTP to even work between switches?
The rules are simple, but they are absolute. First, the VTP version has to be the same everywhere.
Okay.
Second, the name of the VTP domain has to match. Precisely. No typos.
And third,
If you're using authentication, which you should be, the password has to be an exact match too. If any of those are off, the switch just becomes an island. It won't sync.
let's focus on that VTP domain for a second. You called it a boundary. What does that mean in practice?
It's the blast radius. It limits how far a configuration change propagates. A mistake made in domain A will never, ever leak into domain B.
And a switch can only be in one domain at a time.
Only one. And here's a key point for anyone setting this up. Until you actually give a switch a domain name, you can't create or modify VLANs on it, and it won't propagate anything. It just sits there.
So it's the start button, really.
It is. Now that we've set the boundary with the domain, we can talk about making the traffic flow inside that domain more efficient. That brings us to VTP pruning.
Pruning. It sounds like you're cutting something back.
That's exactly what it is. It's about selective traffic reduction, and it's a huge bandwidth saver.
How does it work?
Okay, so normally when a device sends a broadcast, like an ARP request, that frame gets flooded across every single trunk link in the whole domain.
Even to switches that don't need it.
Right, even to switches that have no users in that specific VLAN. It's totally wasted bandwidth.
So pruning stops that.
VTP pruning actively prevents it. It checks to see which VLANs are actually in use on the other side of a trunk link. If switch B has 0 users in VLAN 10, the trunk link to it gets pruned for VLAN 10 traffic.
So switch A just stops sending broadcasts for the marketing VLAN down the wire to switch B, where only the engineers are.
Precisely. It intelligently stops that redundant flow. It doesn't just simplify management, it actually optimizes the network's performance. It's disabled by default, but turning it on is a quick win.
All right, let's shift into the operational side. When we set up these domains, not all switches play the same role. You've got 3 distinct modes: server, client, and transparent.
Yep, these 3 roles define what each switch can and can't do.
So let's start with the top, the server.
The VTP server is the authority. It's the only one where you can create, modify, or delete VLANs. It holds the master copy, and it pushes any changes out to the whole domain.
Okay, so then the client must be.
The VTP client is purely a recipient. It can't make any changes itself. It just listens to the server, synchronizes its own database, and then forwards those updates to other switches. It's a follower.
And then there's the odd one out, transparent.
Right. A VTP transparent switch is kind of like a neutral zone. You can create and delete VLANs on it, but those changes are strictly local. They are never sent out to the domain.
So it doesn't synchronize with the domain's database?
It does not. But, and this is a critical detail, it still forwards the VTP advertisements from servers to clients that are connected through it.
Ah, so it doesn't break the chain. A transparent switch just kind of ignores the VTP messages for itself, but it passes them along so the rest of the network stays in sync.
You got it.
That seems like a really safe way to introduce a new switch into a network, actually. Put it in transparent mode first so you don't accidentally mess anything up.
That is the textbook safe approach, yes. It's your sandbox.
So how do they all stay synchronized? You mentioned advertisements.
Right. It's a structured conversation using VTP advertisements. It starts with a summary advertisement. This is like the domain's heartbeat.
What's in it?
Just the basics. The domain name and, most importantly, the current configuration revision number. A server sends one out every 5 minutes or immediately after a change.
And if a switch sees a summary with a higher revision number than its own,
That triggers the next message.
yeah.
The subset advertisement. This is the detail. This is the message that says, okay, we just created VLAN 20, we renamed VLAN 30, and so on.
And I see a note here about MTU as well,
Right. It even includes changes to a VLAN's MTU or maximum transmission unit.
which is just the largest packet size allowed on that segment.
Correct. So
Yeah.
any of those granular changes are in this subset ad. It all comes back to that revision number. It's the version control for the entire VLAN database. Every time you make a change on the server, that number goes up by 1.
And the highest revision number always wins.
Oh,
That seems like the single most powerful and maybe dangerous number in this whole system.
you've just hit on the single greatest vulnerability of VTP version 1 and version 2.
What was the risk?
The risk was the rogue switch. Imagine you bring in a switch that's been offline for months, or a new one you forgot to wipe. It might have an old configuration, but for whatever reason, it has a very high configuration revision number.
Oh.
Because the highest number always wins. When you plug that switch in, it would announce its higher number. The entire network would say, oh, that must be the new master config, and they would all synchronize to its old, outdated, possibly empty database.
So you could literally wipe out your entire network's VLAN configuration with one mistake.
Instantly. It was a network admin's worst nightmare. A massive, sudden outage from one simple mistake.
Okay, that makes the evolution to VTP version 3 sound less like an upgrade and more like an absolute necessity.
It really was. V3 is a complete overhaul designed to fix those flaws.
So what did V3 bring to the table?
A lot. First, on the scaling side, V3 added support for extended VLANs.
Right, V1 and V2 were stuck from 1 to 1005.
Exactly. V3 supports the full range, up to 4094. It also added support for private VLANs, which are critical for security in modern data centers.
But the real game changer has to be the fix for that database override problem. How did V3 solve the rogue revision number?
It solved it by creating a formal chain of command. VTP v3 introduced the concept of a VTP primary server,
So a single boss.
a single boss. Now, only one switch in the whole domain can be the primary server, and only that device is allowed to make changes and increase the revision number. All other servers are secondary.
So if you plug in that rogue switch with a crazy high number,
V3 just ignores it. Unless that switch is the designated primary server, its revision number means nothing. It completely eliminates that accidental override risk.
that's a fundamental shift. It's not highest number wins anymore. It's only the authorized primary can update. That's huge for stability.
It is. But there's more.
Okay.
V3 also lets you configure VTP on a per-port basis. Before, it was all or nothing for the whole switch. Now you can disable VTP on a specific trunk port if you want, which is great when you're connecting to other networks.
More granular control.
Much more. And it has better authentication options and is backward compatible, which helps with migrations.
So let's bring this all home. For you, the person listening who has to manage this stuff, what are the big takeaways? What are the real advantages of VTP?
I mean, it's true plug-and-play configuration. You define a VLAN once on your primary server, and boom, it propagates instantly and, more importantly, accurately.
You get absolute consistency, no more configuration drift.
Exactly. And it just crushes the management overhead. Instead of 100 logins, you have one. The system does the rest. It really turns network scaling from a huge headache into an automated utility.
That ability to guarantee a 100% consistency across hundreds of switches with a single command, that's the real power here. VTP just turns it into a database replication problem.
That's a great way to put it. So to recap, VTP, and especially V3, transforms the complexity of managing large segmented networks. It centralizes the database and ensures rapid, accurate consistency, all while fixing the major security flaws of the past.
And let's leave you with one final thought. We talked about VTP pruning, right? The idea of stopping unnecessary broadcast traffic from crossing your trunk lines.
Right, for efficiency.
By reducing that wasted data, VTP pruning doesn't just manage traffic, it fundamentally optimizes the network, which raises a broader question for anyone managing infrastructure. How many of our complex networking problems, latency spikes, high CPU on switches, are actually just solved by controlling the unnecessary spread of data? Think about how often the solution isn't adding more bandwidth, but just removing what doesn't need to be there in the first place.
Thanks for listening. If you found value in today's episode, please subscribe and leave us a review. It helps more people find the show. See you in the next one.
Hey, yo, haven't you checked out our new book yet? Link in description.